Can this sofa fit through a door with a width of 80 centimeters? Maybe if we put it on its back and tilt it a little bit. From now on, let's call the gain that this produces slack. In this image, the slack is indicated by the width of the small red arrow in the upper left corner. Here we have what could be considered the envelope containing our sofa as seen from the left side. Geometrically speaking, this figure is a trapezium. Let's put the sofa on its back. There we are. Now let's tilt this configuration a bit around point D. Point D is the pivot of the rotation. RD has now become a vertical line segment. In this figure, we have drawn some lines and designated capitals to all the resulting points. The corners P and Q are right angles. The lines that seem to be parallel in the picture are what they seem, parallel. Therefore, both PQRS and PQCD are rectangles. PD is the height of the sofa and equals 90. QR is the arm height and equals 50. PQ is the depth of the sofa and equals 85. XY is the slack we previously mentioned. It is also the unknown that we want to evaluate. The first thing to notice is that the angles R1 and D1 are equal in size. This is because of the fact that they are formed by the lines QR and VR on the one hand and PD and XD on the other hand. QR is parallel to PD, and VR is parallel to XD. So R1 equals D1. Or by consequence, cosine R1 equals cosine D1. Which in turn implies the equation on the right side, 50 divided by VR is equal to YD divided by 90. This is relationship 1, an equation with two unknowns, VR and YD. The ultimate goal is of course to gather as much equations as there are unknowns. From this we hope to be able to find by elimination our unknown XY. The second equation is easy to verify. XY plus YD equals XD, which was in fact the segment PD rotated around the pivot D. PD is the height of the sofa and equal to 90. Therefore XD must also be 90. So XY plus YD equals 90. This is equation 2. Now we come to our third equation, which is the Pythagorean theorem applied to triangle VQR. 50 squared added to VQ squared equals VR squared. This is equation 3. For the fourth equation, we take a look at the rectangle PQRS with area 50 times 85. It consists of two green-colored right-angled triangles and the orange-colored parallelogram. That the two green triangles added together have a total area of VQ times 50 is fairly easy to see. That the area of the orange-colored parallelogram equals VR times RE can be seen by rearranging some triangles. Namely in the following way. Here we swapped the blue triangle on the left that was previously triangle TRE with an equal-sized portion of the parallelogram. Now we see that the orange area must be equal to VR times RE. Therefore, VQ times 50 plus VR times RE equals 50 times 85. This is equation 4. Take a look at corner R, which we have divided into 3 subangles. The yellow ones, the angle called R0 and the angle called R1, must be of equal size. After all, if both angle R0 and angle R1 can be complemented by angle R2 to give right angles, then angle R0 must surely be equal to angle R1. This means, of course, that the tangent of R0 also equals the tangent of R1. This in turn implies our equation 5. 40 divided by 85 equals VQ divided by 50. Here we have summarized what we have found so far. Is this sufficient in our quest to determine xy? Actually it is. The number of equations is 5. The unknowns are VR, YD, XY, VQ and RE. Also 5 in total. Provided the equations are independent, this system of equations should be solvable. In fact, it is a simple matter of elimination of the unimportant variables until we are left with xy. Recall that xy was our slack parameter, the value of which we sought to calculate. Here we have the result of the process of elimination. It makes sense to replace all the numbers in the equation by letters so as to derive a more general formula for the slack. This is what our formula looks like. Let's put it to the test. For instance, let us see what happens if we make the arm height equal to the total height of the sofa, say both 90. In that case, the formula returns our S to be 0. There would be no slack at all. This is exactly what we had expected. After all, contrary to what the picture suggests, the sofa cannot be tilted this time. Of course, if all the dimensions were small enough, then the sofa might still be able to pass our door. But in that case, this would certainly not be due to sufficient slack. Now let the arm height A be 0 and height H be equal to depth D. Then the formula changes in the one depicted here. The last formula could also have been found in the following way. Our formula seems to be correct. So here we have it. A formula that some mathematicians call the sofa formula.